Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will differentiate logarithmic functions. So it turns out the derivative of the natural log of x is just 1 over x, which is remarkably simple. So how can I use this to differentiate something like this? Well, let's let y equal the natural log of x squared plus 1. We're actually going to use the chain rule to find the derivative. So remember, the chain rule is dy dx, so that's differentiating y with respect to x. That's what I want to find, is equal to dy du times du dx. So we learned this last semester. The chain rule is also the function of a function rule. We use it here because we have a function, which is the log function, of another function. X squared plus 1 is a function. So what we do is we let u be the inner function. I'm going to let u be the thing inside the brackets. So I'll let u be x squared plus 1. So that means that y is just ln, natural log of u, because u is x squared plus 1. So let's calculate these two quantities. So firstly, dy du. That means I take y and differentiate with respect to u. So using this rule up here, the derivative with respect to u will just be 1 over u. So du dx, that means I take u and differentiate with respect to x. So du dx is just 2x. The derivative of x squared is 2x. Derivative of a constant 0. Remember, constants vanish when you differentiate. So now I've got these two quantities. I have all I need to calculate dy dx. So the derivative of y with respect to x is dy du times du dx. But of course, u is x squared plus 1. So I'm going to substitute this u for x squared plus 1. So you're probably thinking to yourself, oh my God, surely there is a shorter way to do this. Well, there is. Notice what we've ended up with. We've ended up with the function in the brackets on the bottom and its derivative on top. So this is the formula for what we've just found, for those who like formula. When you're differentiating log of another function, its derivative is simply that function on the bottom and its derivative on top. So this only works though when it's log base e. So let's look at a few more examples. All right, I've written the formula again for you, and that's how we're going to differentiate each of these quickly. So to differentiate ln of sine x, what we do is we put the function in the brackets that goes on the bottom, and what goes on top is its derivative. So the derivative of sine x is cos x. And then we're done. Remember, we don't add c when we're differentiating, that's when we're integrating. So how would I differentiate something like this? Well, because it's natural log of a function, all I do is put the function on the bottom exactly as you see it, and on top I put its derivative. So the derivative of 1 is 0, derivative of minus x cubed, so we're going to move the power to the front, decrease by 1, and then the derivative of x is just 1. So there we are, function is on the bottom, derivative on top. So how would I use it to differentiate this? Because this rule only works if it's log base e. How would I differentiate log base 2 of x? Well, I would use the change of base formula. So using the change of base formula, log 2 of x is the same as natural log of x over natural log of 2. So natural log of 2 is just a number. It's about 0.69 or something like that, but it is just a number. So when we're differentiating it, we can kind of leave it alone. This is the same as 1 on ln 2, 1 on natural log 2 times natural log of x. So when I differentiate this, and I should have put f dash x up here as well to indicate that I found the derivatives. So when I differentiate this, I'm going to leave the constant alone. If you're timesing by a constant, you just leave it alone. And then I'm going to differentiate ln of x, and we know that that's 1 on x. So the derivative is actually 1 on x natural log of 2. So we can get another formula for this. So when you're differentiating a log function that's not base e, we'll just call it log base a of x, that is simply the same as log base e of x, but you have to times by the natural log of a. That's the quick way to do this one here. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.